Good morning students, and welcome back once again to another video of laws of motion. In this video we will be talking about the law of conservation of momentum. So the last thing that we studied was the third law of motion, which is action and reaction are equal and opposite. And before that we studied the second law of motion, in which we talked about the momentum of an object. Now this is another one which is related to the motion, as you can see from the name. The momentum is described as the product of mass and velocity. The statement for this law is that if the two objects are in collision with each other, or they are in interaction with each other, then the initial momentum and the final momentum of both of these bodies remains the same. That means if we have a certain object, okay, let's say that this is an object and this is another object. These two are moving in this direction. They are in the same direction. They both have different velocities, but the velocity of this object is more than the velocity of this object. That means this is a slower object and this is a faster one. What happens is they are moving in the same direction. So at some point this object is going to collide with this object. Yes, we know that? Okay. So the law states that the momentum of this object and momentum of this object, okay, we take the sum of this, mathematical sum, and we keep it aside. That is the initial momentum for both of these objects combined. After some time they are going to collide. Now their mass is same, but when this object collides with this object, the velocity of this object increases and the velocity of this object decreases. We know that. So when the velocity changes, the momentum also changes. So before, whatever momentum this object has had is now going to change, and it is going to have a different one. And similarly, this was having a different momentum and now its velocity is increased. So once again its momentum is also increased because there is a change in the momentum. So the initial momentum for both of these objects have been changed to final momentum because their momentums are different now. So both of them have different momentums. We find the value of this momentum of both of these objects and we take a mathematical sum of that. Now interesting thing is the combined initial momentum of both of this object will be equal to combined final momentum of both of this object. So this initial, let's say this is initial object, object A, this is object B. So initial of A plus P final, P initial of B is equal to P final of A plus P final of B. This states that the initial momentum of the first object and initial momentum of the second object, when we find those values and place it over here, it will create the total initial momentum. And the final momentum of this object and the final momentum of this object, when we combine it, once again we get the total final momentum, which is similar to the initial momentum. So if there is no external force acting on it and these two alone are interacting with each other, that means that the total momentum of the system, not just individual, the total momentum of the system remains constant. Their individual momentum might change. Their individual momentum might change and will change, but the total momentum will remain the same. I hope you get it. Okay? You can reverse the video and watch it once again if you have any confusion. Okay? What I mean to say is that the total initial momentum and total final momentum before the collision and after the collision remains same. I am talking about total momentum. Their individual momentums are going to change. Even though their mass is same, but because they are striking with each other, the velocities are changing. Therefore, the momentum is going to change. But the overall total momentum remains the same. Okay? And there is a huge derivation for that. So be ready for it and we will start it. From the very beginning, we know what happens. When this object is striking this object, it is action from the third law of motion, and at the same point this object also applies the force on this one. So there is a reaction. So what happens? When this object A or this ball A applies the action, this velocity changes, and at the same point B also applies the reaction on A. Therefore its velocity decreases. So this velocity increases and this one decreases because of action and reaction. By the third law of motion, we can write force AB is equal to minus of force BA. Why the minus sign? Because the negative sign indicates it is in the opposite direction. Because force AB is in this direction, but force BA is in this direction. That is why this velocity is decreasing. Okay? From the second law of motion, we know by we are going to write this over here by third law. Okay? By second law of motion, we know that F is equal to mass into acceleration. So I am going to write over here mass into acceleration is equal to minus of mass into acceleration. Now what about this? We are going to write mass into acceleration, that is mass into acceleration of ball A and mass into acceleration of ball A over here same ball B and ball B. Understood? We also know by the first equation of motion that A is equal to V minus U upon T. We can substitute that value over here. The same thing happens. This is just for knowledge purpose. A is equal to V minus U upon T. We are going to use this value. Therefore, ma final velocity of A minus initial velocity of A upon time taken. Similarly, minus mass of ball B, final velocity of ball B minus initial velocity of ball B upon time taken. Because time is the same, because they both strike at the same moment, so time is similar for both of this. You can remove time from both the sides, cross multiplication, and it becomes 1. So there is no need for time anymore. What we have left over here, now simply multiply this. So m into V, ma VA minus MA UA is equal to minus MB VB minus minus plus MB UB. I hope it is clear to you, students. Simple mathematical multiplication. Just open the brackets and multiply mass of both final and initial velocities. Now what we do, we take this minus MBVB on this side, which becomes plus. So I am writing plus MBVB is equal to, keeping this MAVA as it is, MAVA, and taking this minus MAUA on that side, it becomes plus MAUA plus this one is MAUB. Okay? Now I am taking whole of this portion on this side. If you know simple mathematical rule, if A is equal to B, then I can also write B is equal to A. The same thing is happening over here. I am using this whole equation on this side, and I am doing right hand side is equal to left hand side. So the next topic is, so the next line is becoming this MAUA plus MBUB is equal to MAVA plus MBVB. I hope it is clear to you, students. Now observe this last point very carefully. Mass into velocity, momentum. But because this is u, that is initial velocity, this is initial momentum. So the next line that I am writing is over here. M into u, that is initial momentum, so I am writing P initial of ball A. Similarly, plus initial momentum of ball B. So P-I-B. And over here you can see mass into velocity, but V is final velocity. So final momentum of ball A, final momentum of ball A plus final momentum of ball B. This statement you can see which we had started in the beginning, that is the law of conservation of momentum, that the total momentum before and after the collision remains the same. So the initial momentum, if we do the sum, it remains the same to the final momentum if we do the sum. I hope it is clear to you, students. It is quite a long video and quite a long derivation. Go through it very carefully, and if you have any doubts, you can write it in the comment section. Till then, have a nice day.